Hi there. In this video, we'll be having an introduction about the conic sections. To start, a good question to ask is that after learning about lines, linear equations, and linear systems, what comes next? Well, the answer to that is conic sections or quadratic curves. So this would be our main topic for this video in this series of playlists. So by the name itself, we'll be using cones to discuss this one. But first, take note that we'll be dealing with quadratic relations out here. So the general form is given by ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. As you can see, the degree here is 2 since the highest degree in a term is 2. So clearly, 2 out here. When you add this is also 2, 2, and so this are the highest since the degree here is 1, 1, and none. So again, this is the standard form of a conic section. Going back to cones, we illustrate conic sections with a cone and another cone. This cone here must be right circular, or that is, the base out here is a circle with the right. So what we mean by that is that this is perpendicular. The cone is perpendicular to the base, or that means this one out here is a right angle. So again, this is a circle and this one is right angle. Other parts include the vertex, or this one is the point in the middle of the two cones. Then we have the upper and the lower cone, just to define that those two. And lastly, the generators, or this one out here, the slanted height. We'll now be using this figure out here to illustrate the 4 major conic sections. So to start this one, first take note that we obtain the conic section by cutting this figure out here using a plane. So the intersection of these cones out here and that plane is what we obtain as our conic section. So to start, let's start by cutting this figure parallel to the base. So if this one out here is the base, try to cut it like this one. So as you can see, we cutted this figure using a plane. So this is one out here is a plane. Upon doing that, when we cut this one parallel to it, we'll obtain something like this. This one out here is actually a circle. So we all know what a circle is, but in the next videos, we'll be discussing more what it is and the mathematical aspect related to it. We may also cut it around this one out here. This doesn't look like parallel, so let's fix this one. There. Assuming that cutted it properly. As long as this plane is parallel to the base, what we'll obtain here is again a circle. So that is one of the 4 major conic sections. So let's write that one down here. Circle. Now, what if instead of parallel to the base, let's try it to be parallel to the generator. So that would look like something like probably something like this. Oops. Try to make this one look nice. So assuming that this is parallel to this one, then what would happen here is that we'll be cutting this figure something like this. And this figure out here is a parabola. So that is another conic section that we can obtain by cutting this figure out here. Again, the key here is that this plane is parallel to the generator. You can also do the same for this side. So let's try that one. Save something like this. Doesn't really look that nice, but it would look like this out here. Again, this one is a parabola. So let's write that one down here. We'll explain more of these conic sections in the next videos, but for now, it's it's nice to have an understanding how and where these came from. So let's clear out some things out here. There. So let's go on with our third conic section. This time, recall that from the circle we cutted this parallel to the base. Now what if we tilt that one slightly? So let's say we cutted it like this one. Then what we'll get here is actually, it would look something like a circle, but it's not a perfect circle. It's like an oval shape. This one out here is what we call an ellipse. You could do the same for this side out here. Oops. Look like something like this. This one out here is also an ellipse. So that is our third conic section, ellipse. Lastly, what if we cut this vertically? Something like this, assuming that I cut it this well. Something like that. Apologies for the poor drawing, but we'll be cutting this conic section around somewhere here and somewhere in here. So what we'll obtain is something like this. This one out here is called an hyperbola. So it's like a parabola, but we have two parabolas, one up and one down. Also take note here that the cutting here is not necessarily vertical. It can be a bit slanted, that as long as it hits the two cones that we have. So let's write that one down, hyperbola. And so we had obtained the four major conic sections. Just to take note, the reason that parabola, if you recall, parabola it must be, when we cut the plane, it must be parallel to the generator. The reason for that is because if it is not parallel, then there's a tendency that, like for instance, here, how we cut it, if we cut it not parallel, see, something like this, there's a tendency that it will hit this cone out here. We might end up with a hyperbola instead of a parabola. So that's something nice to take note of. Now, after these 4 major conic sections, we also discuss other conics that we won't be focusing on, since these are things that we had already discussed in the linear systems or lines. So the first is this one. If we cut this figure exactly and it hits exactly at the vertex, then what we get is a point. So again, when we have a point, we don't really need to dive into that, since it's not that interesting to study compared to these 4 out here. So let's just write that one down. Aside from that, we can also cut this one around here, wherein it hits the generator directly. It cuts through the generator directly, so their intersection is a line, since it only hits the generator. So that is something that we won't discuss as well, since we had already talked about lines numerous times in this channel. Oops. Let's just manually erase one by one of this. There. And lastly, if we cut through this one out here, and this hits the 2 generators, it cuts through these 2 only, assuming that that is correct, then what we get are intersecting lines. Intersecting lines. So let's go out this one. So these are the things that we won't be focusing much on anymore. Just to emphasize, these three are what we call degenerate conics. And these 4 out here are our 4 major conics. To summarize, again, we learned the 4 major conics: the circle, the parabola, the ellipse, and the hyperbola. Aside from this, we also talked about the degenerate conics, such as the point, the line, and the intersecting lines. But then again, we won't focus much on this anymore, as our focus is on the 4 major conics. So you may take a screenshot of this one for your reference. Just to end this formally, if you are wondering what's the purpose of the conic sections, well, learning this has various applications in physics, astronomy, and even in engineering and architecture. So if you want to pursue those fields, you'll encounter this one, and learning the basics on this one will be very important. So that's it. I hope you enjoyed this one, and yeah, that's all for this video.